The log-rank test is the first of two survival analyses that we're going to look at. And in survival analysis, you look at the time to a binary event. It should not be confused with the logistic regression, although that analysis also looks at binary events. The log-rank test is used to compare two groups. You can't compare more than two groups. And to compare the time to a binary outcome between the two groups. It's not included in the base package, so you would have to load a package. And we are using the popular survival package. When performing this analysis, you need to take several steps. The first step is to create a survival object using the command serve with a capital S. And this survival object is then used to make kaplan-meier plots and to perform the log-rank test itself. And to make the kaplan-meier plot, you use the command servefit in order to create a new object containing the data for the plot. And the log-rank test itself is performed using the command servdiff. And I'll show you how this is done. First of all, to perform a log-rank test, you need 3 parameters for each observation, patient or subject in the study. And the first of these parameters is the group allocation, and for the log-rank test it needs to be precisely 2 groups. The second piece of information you need is the outcome, and it should be a binary outcome, for example, died or survived, caught the disease or remained healthy, or something like that. And I suggest that you code it true, false, or 0, 1. True or 1 meaning that the individual has reached the outcome during the follow-up time, while false and 0 would indicate that nothing happened during the follow-up time. And thirdly, you need the follow-up time itself. And the follow-up time is the time that you have observed the subject. And for those who have reached the outcome, for example, had a myocardial infarction, the follow-up time is the time from inclusion in the study or when the follow-up started until the individual reached the outcome. Even if you would know what happened after this outcome, that's not part of the follow-up time, because the follow-up ends as soon as the patient reaches the outcome. For those who did not reach the outcome during the follow-up time is the time that you have observed the individual from the start of the study until data was censored. That is when you stopped looking for the outcome. And obviously, if you would for some reason get information that a patient has had an infarction or died after you stopped following him or her, then you can't extend the follow-up time for that particular individual, but you have to consider him alive or without outcome. In the survival package there are a lot of data sets included, and we are going to use the lung data set, which describes the survival times of patients with advanced lung cancer. And the most important parameters or columns in this data set is the time column, which contains the survival time for each patient in days. That is the time of survival or the total follow-up time in those who survived the entire study. And the column status contains the outcome or the status of the patient. And it's not coded 0, 1, but rather 1 and 2. But 1 stands for censored and 2 for dead. And it works anyway because 1 is less than 2. So they could just as well have been 0 and 1. And then you have a lot of additional columns containing data which could be used as covariants. The first step when performing the log-rank test is to create a survival object. And before that you would of course have to install the survival package and load it using the library command. And then you create the survival object using the serve command. And the serve command takes two arguments. The first one is an object containing the times, that's the time column, and then a vector containing the status of each patient, the status column. And in this case, we store the resulting survival object in an object called mserve, and that's arbitrary. You could call it anything, but in this case we call it mserve. The survival object might sound like a rather fancy thing, but it's really not. If you look at the mserve object, you find that it simply contains the times for each patient, and in those individuals where data has been censored, a plus sign is added to the follow-up time. That's all there is. Two columns have become one. To draw the kaplan-meier curve, which looks like this, you might have encountered it previously. It shows the percentage or fraction of patients who have still not reached the outcome at different time points. And in this case we have separated it between men and women. And to draw this plot you have to create the serve-fit object using the serve-fit command. And the arguments needed for the serve-fit is, in this case, the survival object tilde the grouping variable lang $6, because we want to make separate curves for men and women. And then we simply plot the serve-fit object. We choose colors red and blue, and we make a legend telling everyone that red is male and blue is female. And the order of male and female is because male was coded as 1 and females as 2, making the males come in first here. If you would like to make a single plot for all patients, then you would have provided mserve tilde 1 as argument for the serve-fit command, and then you would only get a single curve. If you want additional arguments, there are a lot of them. You can look at the help text for plot.servefit. To perform the actual log rank test, you use the servdiff command. And as in the previous picture, you provide the survival object tilde the grouping variable. And this is what you get in return. And as you can see, the chi-square has been involved in the calculation, but what you might be most interested in is the p-value, which is 0.001 here, indicating that the difference between men and women in survival time is highly significant.